All right, these are the notes for section 3.3, which is on properties of logs. I think a key thing when you remember, it can hopefully help a little bit when you're doing logs, is to remember that logs are exponents. So whatever do we do with exponents, that's what we do with logs. For example, when you multiply two numbers with exponents together, you add the exponents. Like x to the squared times x to the fifth is x to the seventh. Well, so when you multiply, you add exponents. So if you have logs, if you have the log of a product, which is what you get when you multiply, when you break that down, it's the sum of the two logs. Same way if you divide, like here x to the fifth divided by x squared. When we divide, we subtract exponents. 5 minus 2 is 3. Well, same way with logs. If you have the log of the quotient, so if you have the log of a fraction, you take the difference of the two logs. So you take the log of the top minus the log of the bottom. The log of the numerator minus the log of the denominator. The last thing is if you raise a power to a power, like if I have x to the fifth to the second power, we raise a power to a power, we multiply exponents. So 5 times 2 is 10. So when you raise a power to a power, you multiply exponents. So if you have logs, you can take the exponent times the log. So let's go down here like this one where it says expand this into separate logs. Notice here we have a product. So it's the log of 5 times x cubed times y. So when we break that down, we add those. So you're going to have the log of 5 plus the log of x cubed plus the log of y. So since we have the log of a product, so we multiply them, we break it down, we add the 3 together. Now we're not quite done here because here we have an exponent. So this is a power, this is like a power to a power. So we do that, we multiply, so we're going to take that exponent and multiply it out front. So we have the log of 5, we bring that out front, so that's 3 log of x plus the log of y. This next one. Now first, notice it's a divide problem, so it's a quotient. Now first we have a square root. Let's rewrite that, write that square root as an exponent. So that'll be the natural log, so on top, that'll be 3x minus 5. If I use an exponent of 1/2, that's the same as the square root, so now it looks like that. So now if you can see, we have the log of a quotient. Well, if we divide, we subtract the exponent, so we subtract the logs. So this will be the log of the top, 3x minus 5 to the 1/2, minus the log of the bottom. So if I break that into separate logs, I take the log of the top minus the log of the bottom. Now again, see we have an exponent on this one. Remember, if you have an exponent, you multiply it out front. So we bring that 1/2 out front. So we have 1/2 the natural log of 3x minus 5 minus the natural log of 7. So that's breaking them into separate logs. So again, if you have a product, you add the separate logs. If you have a quotient, you divide the logs. You subtract the logs. If you have an exponent, you multiply it out front. Those 3 things. All right, these next 3, we're going the opposite direction. Combine as a single log. Well, first, this number out front. Now here, when there was a number out front, didn't that used to be an exponent? So that's the first thing. Let's put that back. There's the 1/2 in front of this log of x. So let's put that back. That'll be the log of x to the 1/2. Here, there's a 3 out front. Let's put that back. That'll be the log of x plus 1 cubed. So that's the first thing. Put the exponent back. Or put the number in front back as an exponent. Well, now we have the sum of 2 logs. Remember up here, when we multiplied, when we broke that down, we ended up with a sum. So here we're going backwards. So let's have the sum of 2 logs. If we want to combine that as a single log, we're going to multiply. So it's going to be x to the 1/2 times x plus 1 cubed. So we wrote it as a single log. Once you combine it, the word log will only be in there one time. Here, if you wanted to, We could write that as a square root. It could be listed either way. You could write it as the square root of x times x plus 1 cubed. You could write it like that. All right, this one, same thing. Here there's a 2 in front of the log. Remember, anything in front is an exponent. Let's put it back. So that's an odd natural log of x plus 2 squared. Here there's a 1/2 out front. Let's put that back. So put the 1/2 back as an exponent. So it looks like that. Now, if we subtract 2 logs, if we want to combine that, we need to divide the 2 logs. So the x plus 2 squared goes on top, and the x to the 1/2 goes on the bottom. And again, if you wanted to, that x to the 1/2, if you wanted to write that as a radical, you could. It should be okay either way. So those are the same answer. Okay. Now this one, notice we have a 1/3 out front, but all of this is in the parentheses. So let's take care of what's in the parentheses first. So I'm going to leave the 1/3. You always start inside the parentheses. Well, here I can't do anything with the log base 2 of x. But here I have a 5 in front of the log. Remember, if there's a number in front, let's put it back as an exponent. So that'll be x minus 4 to the 5th. Now, still inside those parentheses, we have a plus. So we're adding these 2 logs together. So let's leave the 1/3. If we combine those two, if it's add, if you combine, you multiply, so that'll be x times x minus 4 to the 5th. Well, now we still have a 1/3 in front. Let's put that back. Anything in front is an exponent. So that is all of this. We had all of that there. Now that's all to the 1/3 power. So all of that was there. That's all to the 1/3. If we wanted to, 1/3 is like a cube root. We could write this as the log base 2 of the cube root of all of that. Okay. This next one uses those same properties. It's a little more complex. Is that we have 2 things to go by. We know the log of 3 is A and the log of 5 is B. That's all we know. Log of 3 is A, log of 5 is B. We want to write this log of 75 in terms of A and B. That means, since all we know is the log of 3 and the log of 5, we need to break it down. So we need to find some way to write 75 using only bases of 3 and 5. Well, let's see. We know 75 is the same as 25 times 3. So there's a 3, so that looks good. 25 is 5 squared. So we could write 75 as 5 squared times 3. Well, let's do that. Instead of the log of 75, let's do the log of 5 squared times 3. Well, here we're multiplying those 2. So if we want to separate this into separate logs, we're going to add. So we take the log of the first plus the log of the second. Now there's an exponent up here. Let's get that out in front. So 2 log 5 plus log 3. Well, now we know the log of 3 is A. Well, here the log of 3, let's replace the log of 3 with an A. We know the log of 5 is B. So let's replace that log of 5 with a B, and it still has a 2 in front of it. So now we have 2B plus A. We expressed it in terms of A and B, and we're done. Same with this one. We have log of 9 over 125. All we have to work with is 3 and 5. So let's see. We know 9 equals 3 squared, so that gives us a base of 3. We know 125 is 5 cubed. That gives us a base of 5. So we rewrite this. This is the log of 3 squared over 5 cubed. So we got bases of 3 and 5. Well, let's break that down. That's the log of a quotient. So that means the log of the numerator minus the log of the denominator. There's an exponent of 2. Let's move that out front. So let's multiply that out front. Here's an exponent of 3. Let's multiply that out front. Well, now we have the log of 3. Well, we know the log of 3 is a, so that's 2a. Here we have the log of 5. We know the log of 5 is b, so that's minus 3b. We wrote it in terms of a and b, and we're done. So first you need to break it down into these two logs that we know, and then substitute in. So you need to break it all the way down. Now let's go back to this first thing. The important thing here is called the change of base formula. You use the change of base formula when you get a base that's not on your calculator. Because when on your calculator you have a base 10, that's the log. You have a base e, that's ln. Well, what if it's a different base? Like what if it's 8 or 9 or anything like that? Well, for that we have the change of base formula. The change of base formula says if you want to find the log with a different base, you take the log of the value, so the log of x, divided by the log of the base. Here our base was a, so we divided by log a. So the log of the value divided by the log of the base. And also it doesn't matter, even if this says log, we can use the log button on our calculator or the ln. It doesn't matter. It'll give us the same answer no matter what. So if we were doing this one, log base 8 of 5. So we take the log of the value, which is the log of 5, divided by the log of base, which is the log of 8. You do that on your calculator, you get 0.774. Again, on your calculator, you just hit the log of 5. So again, you could use either log button. Let's say if I use the log, the log of 5, divided by the log of 8. We get 0.7739, so 0.774. Or this one, log base 9 of 20. Let's say I want to use the ln button this time. Again, it doesn't matter. Either one works. I can take the natural log of the value, 20, divided by the natural log of the base, 9. And you just do that on your calculator. So let's say I use the ln button. So you press the ln of, what was it, 20? So ln of 20 and hit enter. Divide by, and then hit ln of 9 and hit enter. 1.363 for 3 decimal places. So change your base formula. Take the log of the value divided by the log of the base. The log of the value divided by the log of the base, doesn't matter which log button you use. If you have the log of a product and you want separate logs, you add the two logs. If you're going backwards, if you have the sum of two logs and you want to combine them, it's the log of the product. If you have the log of a quotient, if you're dividing, you take the log of the numerator minus the log of the denominator. Or going backwards, if I gave you the difference of two logs, if you want to combine them, it's the log of the first divided by the second. And the word log will only be in there one time. Then exponents. That's not right. That should be the log of, that u shouldn't be a base. That should be u to the nth, like that. So the log of u to the nth, we take the exponent and multiply it out front. Or if you're given a log with a number out front, you can put it back as an exponent. And I believe that does it for 3.3.